Hi folks, we're going to take a look at page 473, number 11, and they tell us that we have 3 tennis balls that are fit tightly in a can, so just so that they can't move. And in part A, they want us to determine the minimum volume of the can to the nearest tenth, and in part B, they want us to calculate the aluminum needed to create such a can. So in other words, the aluminum, what the can is made of, is just on the exterior, so we're just looking for the surface area. Okay, so let's start with A here. So if we're looking for the volume of this can, well, it's a cylinder, so our formula is pi times r squared h. So what we have to figure out is what is the radius of this can and what is the height. Okay, so let's start with the radius. Since these balls fit tightly in the can, I know that the radius of the can is just going to be the same as the radius of one of the tennis balls. So since the diameter is 8.4, I just divide that by 2, so 4.2 is going to be the radius. Okay, and the next thing that I have to calculate is the height of this can. Well, since we have these 3 tennis balls that are placed one on top of the other, again tightly, I realize that the height of each tennis ball is just the diameter. So I've got 1, 2, 3 diameters that make up the height of this can. So h is equal to 8.4 times 3. So 8 times 3 is 24, and 4 times 3 is 12, so that's 1.2. So we've got 25.2. Okay, of course, do it in your calculator if you need to. And so now we have all the information we need to find the volume. So the volume is just pi times the radius squared, so 4.2 squared, times the height, which is 25.2. Okay, and let's calculate that here. So we've got pi times 4.2 squared times 25.2, and that gives us 1396.5. So they want it to the nearest tenth, so we'll do that. So this is equal to 1396.5. Okay, and in this case here, since we're looking for volume, it's centimeters cubed. Okay, so please make sure you get the correct exponent on the length measure. Okay, so here let's do B, and now we're looking for the area. Okay, and the area, and they're telling us to include the lid and the bottom of the can, so that means I need to include the 2 circles. So 2 times pi r squared represents the top and the bottom, and then I have to add the lateral area, the side, which is given by 2 pi r h. Okay, and of course don't forget to refer to your formula sheet in case you don't remember these. Okay, but now I have all this information because I found it for part A. So I've got 2 times pi times 4.2 squared plus 2 times pi times 4.2 the radius times 25.2 the height. Okay, and they'd want this to the nearest square centimeter, so to the nearest unit. So I'm not going to keep any decimals. Okay, so let's put this in a calculator. We've got 2 times pi times 4.2 squared. Okay, I'll press the equal sign there so I can see what I have on my screen, and I'm going to add to that 2 times pi times 4.2 times 25.2, and that gives me 775.8, and since I'm rounding to the nearest unit, that's going to be 776. So 776, and since it's area, it's centimeters squared. Okay, so just a quick recap here. I had to use the information given to me so that I had these 3 tennis balls, one on top of the other, that fit tightly into the can. Hence, I was able to use that information to find the volume, the dimensions of the actual can, and then from there I was able to find the volume.